Okay, it's recording now. All right, welcome everybody. Tonight is the 15th of June. This is Dallas Personal Robotics Group Robot Builders Night Virtual. My name is Carl Ott. I'm the current president, and we'll do what we normally do in these Tuesday nights weekly sessions. We'll go around the table and talk about our robot projects and either boast or ask questions or ask for sympathy, however it may goes, or just some random off-topic discussion that can go any which way we want. So tonight we have an awesome starter. So Pat from Ontario, Canada, take it away.
Okay, so after last Saturday's meeting, I was considering just buying a wind-up motor for my robot. Just looking at what was involved in that program, as we were discussing earlier, how simplified it was and how nice and clean. It just makes me shake my head a little bit. But I did break down, and I bought a new toy.
Ooh.
So I broke down. I bought a four-wheel drive chassis from through a Canadian Polulu vendor, and I'm going to make that my outdoor robot for the competition in August.
Hmm.
So I'm going to throw a Raspberry Pi on top of it and an Arduino, maybe two, and see where we can go with it. I figured I'd give myself a little bit of a head start instead of building something from scratch. Shows up, all I had to do was put the wheels on.
Pat, is that the Daegu wire thumper?
Yep.
They have six-wheeler version I've seen, which is really solid. So
Yeah, they did have the six-wheeler version. I didn't know if I wanted to put that much, another $100 into it. And so already this one was about $250 to get here. So I said, I'll bite the bullet and leave it at that and see where we can go. So I bought some batteries. I bought some LiPo batteries and a charger. And I've already got a Raspberry Pi and an Arduino and a dual motor driver. So I will set it up and see how we can go.
Yeah, looks nice. I've had good luck with my four-wheeler, so I think it'll work for you.
Yeah, I'm a little worried about if there's a curb. It's got 5-inch tires. I don't know how much it can climb up a curb, but we'll see. We'll give it a try, hopefully in July in the back park here. And
there's a YouTube video of the six-wheel version climbing upstairs.
Yeah, I did.
So you'll be fine.
Did that not come with the motor driver? Did you have to get the motor driver separately?
I had to get a motor driver separately.
Well,
Bare bones chassis, I guess.
where did you get the motor driver from?
I bought a Polulu knockoff off of AliExpress. So it's a dual VNH 5019.
Oh,
just plugs into it's on a shield, plugs into an Arduino. So the only thing I didn't like about it is it doesn't have encoder feedback. So I'm going to have to see how I'm going to deal with that, whether I break down and replace two of the motors maybe with two encoder motors, and that should get me pretty close with that and an IMU.
Was that a whole kit, Pat, or did you mix and match a few things? Like
That was a complete kit, the way it stands: 4 motors, wheels, and the chassis, and the wiring for the motors. So basically, it showed up. All I had to do was bolt them 4 wheels on.
Cool. Can you put a link for that in the chat?
I can I'll put a link from Polulu in there.
Okay.
Pat, you gotta show is the coaxial axle.
Yeah.
That's the beauty of this unit.
So the motors are basically, I don't know if you can see that.
Oh, that's pretty wild.
So
Yeah,
they're
you grab onto the ground. That's why you could go over obstacles easily.
So it's got quite a bit of quite a bit of play in it, and they are adjustable, so you can adjust how much spring tension is in there.
So it's 4 motors, 4-wheel drive.
It's 4-wheel drive. It's 4 motors. I'm going to drive it with 2 drivers, not 4.
Yeah.
And that should be good enough for what I'm doing.
Do you know
where are you going to mount the battery?
There is a little spot inside there, so right in here. So I picked up a couple of 5,000 milliamp hour lipos, 7.4 volt, I think. So I'm gonna drop them in there, and I picked up 2 so I can charge one while I'm running one.
Should run a long time on that.
Yeah, I'm not anticipating much weight like I am the other robot I'm working on.
7.4 volts. Are you gonna you're gonna have a separate power supply for the Pi, I assume, or are you just gonna have a buck converter?
I'm probably putting a buck converter for the Pi.
Yeah, I was just gonna ask what you're planning to do, because I've been getting a lot of under voltage on my Pi, on my robot vacuum cleaner, and I tried a number of different things that were recommended out there. I think eventually I got it to work, but maybe it's the Pi 3 that's more sensitive to under voltage than the Pi 4, but even the Pi 4 on my Romi platform, I get a lot of under voltage when I always have something plugged into USB, maybe that's part of it.
But if you're seeing an under voltage message like on your console, that may be an erroneous error. You might want to upgrade your Raspberry Pi, the Raspbian or the Ubuntu or whatever OS you have, because that was a very common error, and it was because they changed how the hardware works, and it doesn't report it exactly the same way. And so I did an upgrade when I got my Pi 4, and that kind of went away because I was getting that, and I wasn't plugging hardly crap into nothing. And so that might be what you're saying. Then again, you might just have, if you got a single voltage source, you're kicking in motors, you're going to get a current spike and a lag and all that other kind of stuff. So
I seem to be getting more on the Pi 3 than on the Pi 4. But yeah, I think it's up to date, but I don't know if there's something different I need to update on the Pi 3.
I have no idea. It's just a neuron fired, and I did the old mental vomit out, and hopefully it helps.
From what I've read, that appears to be a fairly common problem with the Raspberry Pi, especially if you don't get a hefty power cord for the Pi. Some of them have such thin wires in their power cord that a little bit of resistance there will drop the voltage down below that tiny little threshold that they have for tolerating low voltage.
Yeah, a lot of them are number 24 gauge or 26 gauge wires on the cable, which is you're not even good for an amp and a half, and you're trying to peak 3 amps through it, so you're getting a voltage loss.
Yeah, I have a Pi 3 with Octopi on it for my 3D printer, and I just ignore the under voltage message. You see it all the time.
It throttles back for the most part and just carries on.
So the under voltage message is that lightning bolt?
Yeah.
So if you're getting it a lot, you can look for a heavier cable, 20 gauge or so on the for the USB cable, and that should get rid of your problem if you have a good power supply.
So getting back to Pat's description of his new base unit, you said you're going to do 2-wheel drive. Does that mean you're going to do both motors on each side acting as one motor for the
Yeah, so I'll have a left motor driver and a right motor driver.
Okay, and it drives 2 motors on each side. Yeah. Okay.
Can you show me the suspension more closer? Can you get it closer to the camera, the suspension? I'm curious about that.
Okay, let me get back to my other camera. I stole my work camera to do this.
Ooh.
Well, since I set up a home office in the back porch, well, that's
well, the front on, not necessary under. I'm curious how. Okay.
So the motors look like they sit in some sort of T housing, and they actually.
Yeah, so they've got, and it's hard to get in there. I don't know if you can see it.
Yeah, that's a good view.
Spring assembly in there.
Yep.
Are they cross-coupled somehow?
Yeah, they're cross-coupled. I'll get a picture to show you guys.
And it looks like the motor's encased in basically the T-sprayer. It looks like, and then basically the T-sprayer runs it to a troughs.
So
they're cross-coupled left to right.
Okay, yeah.
They're independent.
So you
The
can see
spring
they're
goes between.
independent. So they're at the back. There's a cable keeping them from both dropping down. So it sort of links the two. So if one goes up, the other one goes down. But then there's a spring as well between the two motors, a coil spring.
Looks pretty effective.
I don't
Well,
know.
I guess it's a real shame that there are no encoders.
Yeah, so they've shown how people modify them to put encoders. So I thought about doing that, but it is a little bit difficult. You got to hack and cut out of the way, and
Optical flow.
I'm not sure how to do it because it doesn't involve wood.
Oh, Pat, I was thinking of you. Did you see the Europeans, some Scandinavian design firm launched a wooden satellite?
Yeah, I saw that.
I did not see that. If you find a link to that, let me know.
We should find that and send it. Yeah, it's all wood. It's got a thin layer of metal coating or something, but except for the electronics and the random IoT sensors they've thrown in, a little nanocube, it's a birch satellite.
So
Maybe
IKEA lost the
IKEA was
satellite.
a subcontractor or something. I don't know.
Is
I'll
that
see
the
if I
IKEA
can find it
satellite?
and send it to you.
Okay,
And it
I'll
folded,
post
it
that
folded
link
down.
here
It started
shortly.
out as a collapsible satellite in a thin pack. No, just kidding.
It's like the IKEA of satellites, basically, but
The IKEA, right?
It comes with an Allen wrench to assemble it.
Yeah, there you go.
and it only takes 5 hours for something that, yeah, okay.
There's a chat entry on the satellite.
Oh, thank you, Doug.
Lulu makes a
Yeah.
bunch of good encoders. This one's a 20 count. It's magnetic. It may fit on the back of the motor. I think they make them for the 20D. Yeah, 20 millimeter motors. So if those motors are 20 millimeters, that may work.
But you need an
so
extended
they're
motor shaft,
25
right?
They're 25 millimeter motors, and it's not a dual shaft motor. Doesn't have the extension
Oh,
at
it
the
isn't.
back.
Ooh.
So I could probably get away with just buying the motor and not the reducer,
Mm-hmm.
but it may just be easier to buy a set of motors with the
Yeah.
with the
encoder.
75-to-1 reducer and the extended out the back for the encoder. What the guy did on the that I saw online was he drilled out the back of the motor holder where the T is there. So he slipped the motor in, poked the shaft through the back of the plastic, and then mounted the encoder on the outside.
Oh, okay. Yeah.
So it was an interesting idea.
Mm-hmm.
I suppose if you got really creative, you could put an encoder on the wheel and just read the wheel as it turns.
Yeah,
Mhm.
that's the other option is read the wheel. I was thinking about getting one of Murray's optical flow sensors,
There you go.
but I don't know how well it would work in tall grass or that sort of thing.
Well, you figure they use them in drones to maintain hover position, but that's a little different from measuring distance as you move across wavy fields of amber green or something, I guess. I don't know.
Yeah.
If you put it above the grass, I bet you it would work because I tried mine out on my back patio. I just pointed it in a direction and it kept it pretty much pointed, wherever I positioned it initially when I set it down. So I was kind of, impressed by that it could actually figure that out even as parts of the scene were going by it, it still seemed to, pillars and stuff or square brick columns, and it still stayed on track. So
Yeah, so that's the other thing. I don't know if I go with an encoder count and count position all the way, or go with the GPS and just get into the neighborhood with a GPS and figure it out with a camera.
RTK and camera, why not?
Well, I don't even know if you need RTK. Do you got to be that accurate? If you're within 10 feet and you spot the cone,
Yeah.
You know,
Close
why,
enough.
why RTK? I don't have to be a half inch away.
It's a lot less expensive, that's for sure.
Yeah, exactly. So
Yeah, but don't I mean, that's 10 feet, but doesn't GPS only really get you to 30 most? That you can only depend on 30, right?
who can only depend on 30?
Yeah.
But 90% of the time, you're 10 feet.
It's
Yeah.
cool. Got it. Because I never played with it. I just heard you folks talk, and I was basing that on what my experts have told me. So
I don't know. My car isn't RTK, and I managed to get to my destination.
your car is 20 feet long too.
That's it for me.
Cool. Good update. Boy, that's encouraging. We're going to have some nice competitors coming up in August.
Yeah, so it's part of the problem. I got to find an orange traffic cone to practice on as well. All of them I can find up here have reflective stripes.
That's okay.
Well, apparently in the instructions it said they were you can't use reflective stripe.
I thought I saw that they were allowed. Why don't you send a mail to the send a mail to I don't know, to Doug and me, and we'll sort it out for you, Pat.
Okay.
I'm pretty sure Donna had the same question because they were out of stock at Home Depot, and I'm pretty sure that they were allowed, but I could be wrong.
Yeah, well, if I can use one with a reflective stripe, well, all I got to do is drive by the street and pick one up at night.
Oops. Yeah.
No, I'll just borrow one from the town. And,
Just borrow. It happens. Yeah.
Yeah, and I'll borrow it and bring it back when I'm done instead of buying one.
Yeah.
Or 3,
They
depending
won't
how
miss
well
it
they
for a
work.
couple weeks.
I found 2 that were run over, but yeah, I kind of straightened them back out. So that's what I'm using.
Well, that's it. It's. I'd rather put, you know, they're $15 a piece. I'd rather put, you know, $30 or $45 into a robot than into a traffic cone.
For
In
sure.
my son's school, they used to put traffic cones, and occasionally you'd see a car driving away with one under the bumper.
Yeah, there you go. That's where I think mine spent some time.
You know, one of the trick I picked up for training your computer vision for picking up color, I used Pixie 2 and I messed it with it on different lighting. And then what I found out was if you have the picture show up on your monitor where it's backlit, and then train on that, for me that worked awesome compared to like trying to find the optimal lighting for it. So definitely give that a try if you have a hard time finding the cone with the right reflection. It worked best for me.
Okay, I might try using. I'll probably be using OpenCV and then trying to train it with the hue and a saturation, which is a little more forgiving than an RGB color code.
Yeah, Kevin, that's cool to hear. I was wondering if you could just look at just go to Google image search on orange traffic cone and train it on whatever you find there.
Yeah, I don't know what it is that coming through the monitor that seemed to be better than any other lighting that I use for training.
So what you're saying is you literally pointing the camera at the computer screen?
Yeah, on the picture. Yeah, and so definitely consider doing that as part of your experiment.
As part of the training. Okay. Interesting.
Got it. If you can't find an orange cone, this orange construction paper works really good too. It's like a 2 foot by 3 foot sheet that you can just hang somewhere.
Yep.
So,
That'll work for a target. Maybe you can make your own cone with it.
Yeah, cut out cone.
Hey, Kevin, when you did that on your monitor, did your monitor just have the cone image and then a flat background, or did you have clutter in the background with the orange?
Yeah, so in my case, I wanted the orange and yellow ball, and I wanted to use that to train my Pixie 2. And I was able to find the yellow and orange dot with minimum background, and I just blew it like, a size of an orange, and I had Pixie 2 recognize that, and it worked best compared to me trying to find a real object under different lighting. It didn't work. So it worked for Pixie 2 for sure.
Cool.
Yeah, I thought some of the guys were using neutral density filters because the Pixies were too sensitive to light. So it would, kind of bring it back in the range that it would work in as far as the light intensity. I know Steve did that. He just used like a 35 millimeter neutral density filter and 3D printed something that went between the 12 millimeter lens and the 35 millimeter filters that you can get that are pretty common.
I found a polarized filter helps too.
Yeah, like you can get a circular polarizer.
Yeah.
Yeah.
I haven't tried that. I think it's something that's worth trying. My next toy is OG camera, dual lens. So I jumped from Pixie 2 to OG. So.
Oh yeah, you saw that on SparkFun? Yeah, it was pretty cool. I thought pretty reasonably priced too. So
actually, I bought it from eBay from this research who was abandoning. So I ended up getting it for $125 each, and I bought all three that she had.
Say that again. How'd you get that deal?
On eBay, there was a lady researcher who was selling her research equipment that changed at the last minute. So she was selling it for like $170 or something each. So I told her I'd buy all three if you give me a discount. So she said $125 each for all.
Oh, that's cool. Does it take a fair amount of current?
So it comes with a power supply. I really didn't have a chance to play with it much.
Oh, okay.
So definitely is something I wanted to try. But I did read something about using some particular about Woolworth that comes with it. So I suppose it's somewhat finicky.
Yeah, hopefully it's not like 12 volts or something that
No, it's 5 volts.
Oh, it is 5 volt. Okay, yeah. Yeah, I was thinking hopefully it's not a real power hog. I mean, it's it's a fast chip and pretty much the whole thing is a heat sink. So I imagine it's dissipating a fair amount of power. And
what I really like about this one and the choice for Pixie 2 is that it doesn't eat up your computation power, right? It's just a standalone unit and it sends the data to Arduino, Raspberry Pi, whatever you have. I really like about it.
Yep. Yeah. That's for the price too. I think it does more than the Intel D435s and stuff. Because you can get it'll do object recognition and location, so it'll give you a depth and a position on the screen. So I thought that was pretty cool. But, yeah, I think they normally sell for like $199 at SparkFun. So Jesse's discount may come in handy, 10%.
SparkFun original. We can get it for you from Jesse.
Does SparkFun charge shipping?
SparkFun, yeah, they charge shipping.
So someone told me other day in a different meetup, and the gentleman there said that shipping, if you buy it from the manufacturer, the shipping's free. So it's $199
really?
plus tax.
I can take a look real quick. All right. Check out shipping. Yeah, I'd have to actually go through the motions of buying it to figure out if they charge for shipping. They might.
Well, it's worth looking at.
Yep.
Should we move on then? I think was John next.
Yeah, I've done some mechanical fine tuning to my spider leg. Still waiting for parts to come in, which they changed Mouser changing the date again. I wasn't going to get my parts until March of 2022, and they sent me another email says, "Oh no, it's going to be June 25th." It's like I don't know what to believe. So I'm running without overcurrent protection, but with the mechanical fine tuning and some additional programming, I've got the leg, I've been running it through its paces. You can see it behind me. If I run it through calibration, and have each of the joints go through and find the limits of range of motion. I'm running it pretty slow during calibration because I want to make sure definitely sure I don't miss the end of the range of travel and break something or burn something out. But once it's calibrated, I'm a little bit more comfortable with going fast. So
are those like miniature linear actuators in each joint, or?
Yeah, it just in each segment there's a micro metal gear motor from Pololu, and here's the innards of one of the actuators here. You can see I've got a little worm gear that I 3D printed, and the motor just attaches to the end of the worm gear to slide the actuator back and forth. And if I can, now I've got it calibrated, I go flex it in and out.
So have your threads held up on the, your 3D printed ones? Because a lot of times they'll just,
Well,
sort of load and they'll just shear off.
I printed with PETG, and the gears have been holding up so far.
Huh, wow.
Even when occasionally in the past I've stalled the motor, the gears did not break. So
did you ever think of using like a piece of all thread to replace it, or
a piece of what?
It's like a rod that's threaded all the way one end to the other.
The advantage here is that I can print the worm gear with a D-shaped hole for the micromotor that's just the right shape and size.
Oh, yeah.
That's the advantage of 3D printing. You can do essentially make whatever you need to make for whatever application.
Yep.
That's it. That's all I had.
Making progress, even though the global shipping delays are eating into your plans, huh?
Well, I've got basically two possible designs. One of my most recent changes, I went ahead and I just got one set of boards from Osh Park, and this is the one that has a spot for the current sense amplifier. But when I found out that I wasn't going to get the amplifiers anytime soon, I went ahead and submitted another design, which I'm still waiting for from Osh Park, that just uses the voltage comparator on the PIC. So actually saved me board space and will probably do the trick. So we'll see how that works out.
Very cool. All right, who else has some progress in the last week? Who wants to go next?
I have some.
Ed, go for it.
All right. So I've got some electronics mounted up here, and I've got some actual autonomous runs. So I will show
Take
that.
a pill for that.
What's that?
Said you should take a pill for that.
Oh, dear.
Maybe get a gold star if we can see it.
Yeah, I think at least a gold star is in the.
Yeah, so I took a video. Let's see. There. We'll do that. And then, this is the wrong one. Oh, but that is a good one. So I'll show you this one first. This is someone built a radio control tank here, and it's pretty cool. Anyway, so now I'm thinking about putting tank treads on, but okay, so here's my bot, and right now I just have it drive 6 feet forward and stop, but it's some progress. And David's talk got me inspired, and so now I'm thinking, I need to rewrite some of my autonomous waypoint navigation here to simplify things. And let's see if I can unpresent. There we go. Yeah, so right now I don't have the encoders hooked up. That was just running for, I don't know, I think a second and then stopping, because I don't have the gyro hooked up or the encoders. That's the next step. This part was just getting the the motors turning from the teensy. And oh, the other thing I hooked up was a kill switch on my radio control unit, so that's working. I found that's one of the most important things, is to hook up a kill switch first, because otherwise you're running down the street after it. And
That sounds like the voice of experience.
yeah.
Can you use a button on a remote control as your kill switch?
Yeah, so I'll show you what I got going on here. I just use the airplane controller, and I have a little 6-channel turn it on here, 6-channel control. I don't know, can you see the
Oh yeah.
there you go. Okay, so didn't need that anyway. So then I've got that's my kill right there, is the red light, so I can switch it on and off with this button up here.
So are you using a relay to kill the power to your motors with that? Or are you just bringing it into a digital input and reading it?
Yeah, so that's software. So I've got a channel coming in from my receiver here, going into the teensy, and then I've got the teensy actually controls the speed controllers. So that's all software. So my kill switch actually doesn't cut the power; it just cuts the PWM output to the speed controllers.
Oh, okay.
Is it smart enough to detect if you turn the power off in your radio transmitter?
Yeah, so glad you asked. If I turn the power off here,
If it's running and then you turn the power off.
yeah, so if it's running, so let's see. Right now, see the red light's not on, so it's running. So if I hit the power switch here, it'll there we go. Turns the light on.
Good safety.
Yeah. So it can, the receiver is putting out a PWM signal when there's a signal coming in, but then it I think it just cuts the signal and it doesn't send anything out when there's not a signal from the radio. So that's how it tells.
Yeah, when I used to work on the autonomous drones, they wouldn't let us fly it unless there's a fail-safe built in. So if we lose reception, it automatically tends to be powered down and start landing. So you don't have this, 20-pound weapon flying around hitting people.
Yeah.
Yeah, but it's still, you could get in a situation where if you lose the radio link, you can't turn it off. So,
Right. So yeah, that's what this does. If it loses the radio link, it'll shut the motors down.
Yeah. Oh, okay. Well, yeah.
So the chassis, is it DIY or did you use somebody's kit?
Yeah, no, that was my own design. I used the parts from Go Builda. They make these aluminum extrusions, and so I used a lot of those aluminum extrusions on it, and there's the motors and batteries down there. And yeah, no, and then I just used some plastic, and right now I've just got foam board on the top here that I use to kind of prototype things. I'll eventually replace that with ABS probably.
So Kevin, we've been watching Ted over the last few weeks or months here as he's gone from kind of like motors duct tape to 2x4s to this really robust looking chassis. So it's been really cool to watch his journey to get to what he's got now. It looks pretty capable.
Looks
And-
great. Looks great.
Quite an empirical rationale on the ratios and the design of the whole structure.
Looks very orderly.
So who's going to make the next wooden robot?
That would be Will.
Oh,
Ted, how are you programming it?
So I am programming it in Arduino. I already have a lot of code that I used in the SparkFun ABC, but a lot of that was optimized for racing, and that's one thing I'm working on right now is the kinematics of driving the skid steer, which is a little bit different, but actually I have it so that the speed controllers have a mixer in them, so they'll automatically mix it. So I just send it a throttle and a steering, I guess not steering angle, but whatever you call that, a rotation.
Turn command.
Yeah. So it works a little bit like an RC car in that respect, but it's a little bit different. But yeah, David's talk on Saturday really inspired me. So I'm thinking about just starting over and writing it from scratch, kind of following what he did, because that was a really nice design there, David.
Thank you, Ted. I have a question. So
Okay.
are you using the landing gear switch on the transmitter or flaps or one of those auxiliary channels for your safety power?
Yeah, it's this channel here on the top.
So on airplanes, sometimes that's landing gear,
Okay.
or drop a bomb or whatever.
Right.
But it's not one of the prime channels, one of the auxiliary channels.
Right. Exactly.
Do those channels still show up on the receiver as a PWM, one extreme or the other?
Correct. I think it goes from 1100 microseconds to 1800. It's a 2 position. So I just look if it's less than 15 or greater than 1500.
Yeah.
Nice wide range. Okay.
Yep.
Cool.
Yep. That's all I have.
Well, that's 2 outdoor rovers cranking along and one moving even this week. That's great.
Gold star. He had it moving.
Yeah, I'm very excited. It's even running on its own. That's the exciting part.
You get a gold star.
That's like no world of robotics, right?
Ted, thank you for the kind comments, the feedback.
Oh yeah, you deserve it.
I appreciate it.
Okay. Has anyone else got some cool progress in last week?
Well, I can show something I got working while we were talking. It'll be really brief.
That counts.
I want to get my gold star. I got my telepresence robot. Found out that I'd done something wrong in this wiring here for this battery pack. So I put my other battery pack in, and if I turn it on, it goes. Right now it's just going forward. And what you'll notice is that it doesn't go straight forward, so I have to tune the motors. And that's all of my progress for the week, because everything else has been automotive.
You could turn that into a mobile fish tank.
Well, it's not exactly cool, but it's using that methodology that was in the Instructable, so I tried to stay true. I'll do something more useful looking when I do my real one.
Yeah, I mean, you could turn it into delivery robot also.
True.
Did you ever see the one where the goldfish drives the robot?
Yes.
No.
Yes.
That's awesome.
It could be a
Maybe
mobile.
look it up. You'll find a video. Maybe I'll see if I can find it.
He swims around in this little tank, and they sense where he is, and based on which way he's going, that's the way they steer the robot. So he's driving his own little robot around.
Doug,
Yeah,
that
this-
could be a mobile trash can.
Didn't they do that with like a cicada or a grasshopper or a roach or something. The MIT boys hooked one up there to the front of a robot and just couldn't.
It's a cockroach, I think. They actually, I think they could drive it with a RC transmitter.
On a serious note, there was actually a researcher from MIT, and he either used the fly or cockroach and tied his
Got into the nervous system. Yeah.
and it actually drives the robot.
Yeah, that's what I was referring to.
Yeah.
I think they hooked up some sort of little vibrator or something to its antenna, and it would steer away from whichever side was vibrating, so they could drive it around.
You know, can you imagine that researcher as a kid? I mean, he starts off with a magnifying glass, right, and the bugs in the sun, and then he finds a way to get paid to research to attach things to guys' antennas, and yeah.
I want to see that grant proposal.
What a career! Put that on your resume.
So I do have a little bit to show. It isn't grand, but I'm happy about it.
Cool.
Let me see if I can share out my screen. Yeah, we're going to do the entire screen. Yes. I said share. Now I got to say share again after I said share my screen. All right. I'm going to make this go away. Put you in studio mode so you guys can see. But really, what I want to do is show you this. I found these at Micro Center. They made my life a lot better. Where did they go? Oh, I know where it went. That I did not find it. Come on. Really? I found this at Micro Center. $10. And you can look at it, EP0120. I put the link in the chat on Saturday, but we had much more interesting things to deal with and to go over that, so not that big a deal. It's a hat for a Raspberry Pi, but you'll notice it's got fans and an LED, which is kind of cool. I'll turn it on in a second. And so I've been a big proponent that these Raspberry Pi 4s like to overheat everywhere, and I've been trying to cool mine by any manner of crazy stuff. And I can't ever get this thing to stick and go and work really good. So I saw this, and what it does is it hooks on the GPIO, transfer all those pins up the top, taps into the 5-volt power, gives you a little cool light on it, also powers your fan, and comes with a set of heat sinks that you stick right onto your chips. And so you can cool that down so it'll avoid the throttling that you'll get. There's a better look of it installed. They also give you some standoff, so it's a nice secure connection between the Pi and the hat. And then it gives you enough space to then stick a hat on top of that. And so doing all of that, once you put it all together, let me pull up my close-up cam here. This is what I had to print me a new head on my robot because once I stuck all this in, it became too high, and so I made it happen. So as you'll see on the side here, you'll see the stacking where GPIO, the new board, put on my hat that I care about that's got all my PWN junk on it, which is pretty cool. And then I got the LED on, so when you turn it on, you get a nice little glow going on around there. That's just burning power at the moment. It didn't really do a whole lot. But I thought it was pretty cool, and it solved my problem because I was doing crazy noise like this going around and running out of space, and it was just insane. So made me happy, so I figured I would share it.
What supplies the fan power?
The Raspberry Pi itself.
Do you know how much?
So there's enough spare power to drive the fan without
Certainly.
without picking up.
Where it's going to pull it from? You see these couple of pins here, right? Those are like those are like VN basically. So you're pulling it whatever. You're not really pulling it through a whole bunch of chipsets on that. That's just 5-volt power, pulling it off a pin that's coming through the Pi, as near as I can tell. I haven't looked at all the schematics on that, but I think that pin's connected directly to whatever the USB port and power in is. So you
Yeah, can you link that? Because I might be interested in getting one. I have applied for that's getting pretty hot.
So
Does it really have to move a lot of air?
No, it just got to move a little bit. Those fans don't run very fast. I mean, they run fast enough where you can't really see, track them with the human eyeball. But and it comes with a bunch of heat sinks, so I can't show them. They're all buried down in there. But
I mean, it's basically only so many watts that it's generating, so it's not an i7.
No, it's not. But I will tell you, it'll get hot enough, Carl. If you're doing very much on there, you can't touch it.
Okay.
Not for very long.
You lose
You can cook an egg on it if you wanted.
You probably, if you you probably could. But it's not going. It doesn't. It gets really. Well, I don't think it'll burn itself up, but it will throttle itself down. And when I've been playing with the thing, I go to touch the thing, and you know how you're messing around, going, "Hey, how's this going?" Whoa, what is that? It was one of those touches that I get from the heat. That's and so I
first degree burn.
Yeah.
Who did you order that from?
I didn't. I got it from Micro Center. They got a.
Oh, I'm sorry. Right, you missed that.
Yeah, I got it from Micro Center. I don't know if you've been there in a while, but they've got this Raspberry Pi booth thing set up in the middle of their DIY thing, and this was on one of the lower shelves. It's not on the big plethora of thing, but it's on that the DIY Raspberry Pi where they're selling the 400s and all that other kind of junk. It's on one of those lower shelves. I happened to be walking around and went, "Oh, what is that? Oh, I need one of those." And for like $10, $10.99, something like that, it definitely solves the problem for me.
Yeah, it's been a while since I've been to Micro Center. It's a good excuse.
I don't need an excuse most days. I'm just
Well, now that Micro Center doesn't seem to have any computer parts in stock, maybe they'll have more Raspberry Pis and stuff.
Yeah, that's an interesting thing because I asked the folks because I talked about that. They have some parts. It's video cards they don't have. Literally video cards. I asked them a couple of weeks ago, but you're telling me if I need to buy a video card right now, you can't sell me one? I'm like, no, we can sell you one. We've got one left. And this was a card made in 2010, and it might actually get you Excel up on the screen if you were to install it in a computer somewhere. All the rest of it's because all this chip shortage that's going on. This, and what they've done is there were people camping out. Literally, they get trucks on Mondays and Fridays, and there would be people camping out Saturday morning waiting for the truck to show up on Monday. So what they're doing now is you got to show up on I guess it's during the day, Saturday morning or one of the days they have say show up. You have to you can't show up before 9 o'clock. And when you show up at 9 o'clock, everybody gets a number and they do a lotto because they don't want any doing what camping out people do and that kind of stuff. They nipped a lot of that. People whining, well, I was here and they cut in line, and the manager, you need to do something about it because they cut in line. I'm like, man, this is outside my store, and they got all that. I heard really crappy stories. So they said it's not a lotto because sometimes they get 10 cards in a truck, sometimes they get 100 cards in. They have no way of knowing until the truck pulls up and they pull it off the truck and can see the bill of lading.
I hope that's not the beginning of the end because it seems like that's how Fry's got started, right? It was gangbusters, people camping out, and then the next thing you know.
No, I don't think this is the beginning of the end of Micro Center. I think it is truly a chip shortage because I was talking to them and what's happened, right? We're going along in our just-in-time. I think this is where the just-in-time manufacturing has caused us a little bit of a hiccup. Maybe not a fail, but a hiccup because as we're going along with the manufacturing and people are buying and people are requesting and people are buying and people are requesting. And then we had all that whole COVID where everything shut down. And then something started picking up real fast again. And like because they shut down all that manufacturing pipeline, you got to get all that stuff back going again. And it wasn't one of these smooth pickups like this. It was literally everybody's got to have a video card to do stuff, right? And it just went away, sucked out.
And then you throw in the fact that one or two of the plants, there's only like 3 or 4 plants, and one out of 3, went belly up because of fire, whatnot.
Yeah.
So they can't build plants fast enough.
They can't build the plants fast enough, and they just don't have the people to do it. And all those chip fab places, I'm not as familiar as probably some of you are, but I know that there's a ramp up to it, and there's a shutdown, and when you're transitioning between things, there's time that you got to transition between, and there's just a whole manufacturing process there, and it a cosmic collision of stuff going wrong. I believe that's what they're seeing.
Yeah, it makes you wonder when you've seen all of these places come and go, like Radio Shack and Comp USA and Fry's. And I don't know about you, but I think I see a recurring pattern is they get to a point where they try to sell too much and they forget what their core business was.
Yeah.
That's what happened to Fry's too.
Yeah, that's exactly well, Fry's started doing, get this, they started doing stuff on consignment. They wouldn't purchase product. They would do stuff on consignment where we'll stick it in our stores, and when we sell it, we'll pay you your portion. There's not a whole lot of manufacturers these days that's going to do that on consignment. Now, if I'm an Etsy store, if I'm a small person, they do consignment all the time, but that's onesie twosies. If I'm manufacturing, hundreds and thousands of millions of product, I'm not going to give you a bunch of product on consignment and have it come up with shrinkage or loss. You're just not going to do that.
No, it's the just-in-time thing that's biting everywhere effectively. So because they're trying to maximize for the minimum amount they can make.
Yeah.
So it's the 2 lines intersection problem.
The whole COVID shutting down, the plants having problems, had to shut them down for whatever reason. It's just a whole bunch of things happened at the wrong time. And not to mention that everybody decided to now start mining Bitcoin like a mad person. And because they think they're going to make their millions with Dogecoin, Bitcoin, whatever. And those cards are in very high demand.
I literally stopped going to Fry's a couple of years ago because they were basically selling washing machines and blenders and not stocking their wires and components.
Yeah. Yeah, I don't think Micro Center has that problem because they are a computer shop and they are selling computers, and they do sell TVs now, which bug me, but they've been doing that for several years, and they're not like the LGs are selling. They might sell LG, but it's always the higher end stuff that they're selling and that kind of thing. So and for the longest time they were the outside an Apple store, and even sometimes better than the Apple store. You get better prices in their Apple section over there, and some of those guys are really good back there, but that's been a while since I think that's been the case.
Well, I think people like the people in this group are they're a niche market, and every business wants as broad a market as they can possibly get. And I think that's what happens is they go too broad, and then basically they lose it. They lose focus. Yep,
agreed. That's certainly what happened to Radio Shack. No 2 ways about it. They were the original makers, right? They're the original maker space kind of. You want to build something here? Come here to Radio Shack. We'll build some stuff. And they just got into a little bit of RC cars and a bunch of cell phones, and God help you if you left there without buying a battery. I don't know what that is, but
yeah, well, it was the cell phones that did it for me. When I walked in there looking for components, and all I could find were cell phones.
Yeah, no,
I got to tell you, they were an awesome partner for Nokia because it was the Radio Shack partnership that let Nokia become the powerhouse that it was in the Americas.
Yeah. Wow.
And at one point, Radio Shack was the nation's largest retailer.
For Nokia, yeah.
It was the nation's largest. They had more retail outlets than any other retail.
Well, that was their one big advantage was distribution.
Yeah.
I think to John's point, though, Radio Shack, it's not Telephone Shack. They started back in the 50s and 60s when there was all this home, this huge burst of home construction and electronics, Heathkit and all those things were happening.
Popular electronics.
and they fed into that. And then they lost their way. They went seeking new paths in the wilderness and got hopelessly lost. Just as the maker movement started back up,
Yep.
you know, their natural customer base, and they were trying to sell everybody, you know, cell phones and electric guitars.
But at the tail end, they tried to get back to it, but by then they were too late.
Well,
So,
the
yeah.
Radio Shack brand does exist on the web now, but it's just a smattering of stuff that it's mail order only, near as I can tell.
Well, in the old days, I'd go into a Radio Shack and there'd be rows and rows of electronic components and kits and all kinds of things. By the end, they put all that stuff in a big drawer, big set of drawers, you know, and they'd have a couple of each one. And they wanted to know my phone number when I bought $1.19 worth of parts.
Yep.
Is there a price in Texas? Price Electronics?
Yeah,
Yeah.
we started
Several
with
here in
Dallas,
Dallas.
So I really got bent out of shape when they closed down. Just to me, that did it.
Yeah, I don't know. I can't even imagine what happened to all of Fry's on that stuff, because they were the shizzle there and they were doing a really good job, and then they just stopped getting stuff. And I kind of feel sorry for those employees, because I was in there one time and somebody wanted a thing, a printer or something. And somebody asked, well, you guys don't have any printer? Well, no one else has them either. Well, you need to go to another store, because right down there at Best Buy, half a mile from here, has got 50 of them in stock. So I don't know what you're talking about. I don't know what thing. I have no idea. I don't know. I have no idea what that.
You know, Harold, the same thing happened with Sears. They started off as a catalog company, you know, where you would order out of a catalog and then it would be shipped to you and delivered.
Didn't you like order
familiar, you know?
Yeah, you could like order a whole house or something from Sears or something.
And then
right?
they went to these brick and mortar stores, and for years, I mean, that's great, Craftsman tools and everything, but their basic paradigm would have been perfect for, you know, the internet age.
Yeah.
To order from a catalog and have it delivered to your house.
They could have owned Amazon, right? How did Bezos do what he did to Sears?
Yeah, I just
How
think
on earth?
they didn't see it coming.
Not at all. So who
Anybody have any
else has-
robots to talk about?
Yeah, any robots tonight?
Yeah, robots. Hey, PID controller.
Hey, I can share something.
Cool.
Yeah. So let me see. Okay. Hey, so it's not my robot. It's more of something I was reading about the state machine. I found a good book, and I want to ask you guys something. I'm going to post a link here. I'll share screen real quick just to show you guys what I'm talking about. So, I mean, state machine, I mean, I programmed C++. I recently changed job. I think I told you guys earlier. Basically, it's a complex robot. And so over here, I'm showing one book. Right now, I'm learning this state machine, right? So I posted the link there. But I mean, I was reading. So it's kind of a different, the state machine design or the transition between state is really different from C++ thinking. And I just realized that I wrote states, this kind of state machine before when I deal with complex behavior when I do coding, but it's rare. I want to ask you guys, like, is state machine important for robotics for you guys?
Yeah, sure.
Can't do it without it.
Do you guys use it? I mean, when I wrote state machine, it's really like a rare case where I just code out. I wrote the state transition and I implemented. Now I'm using this kind of a commercial tool to draw states and generate, and it's complex. I realized I was like, You just draw a few boxes there, and that tool generates C++ code. There are cases that it's not trivial, so it's easy to miss. But what do you guys do when you want to implement a state machine?
I mean, think of it as just a way of avoiding a big mess of if, else, and another nested if, and another nested if, and
That's
yet
right.
another,
Yeah.
just think of it as avoiding a big spaghetti of if and else. That's really it, right? But that's what it helps you do. That's how I use it, really.
So what I've done with robotics in the past is have a state machine kind of at the top level. So I have different states like maybe user configuration, halted, navigating, that sort of thing. And then depending on what state it's in, a different part of the code will run for doing that. And then, when
right.
you're
So you basically have put it on the paper and code it the way the transition, code out the transitions. Right.
right. So that you'll go from like running to halted and you'll figure out those different transitions.
Yeah. I see. I mean, that's kind of what I do basically to see what the code, the logic or the flow of the code. And I mean, I'm seeing this book. This book is talking about implementing this kind of a thin layer of state machines. And so you don't go to that extreme, right? Like implement a kind of a generic framework, this framework of a state machine, then
well, what I've done is something very simple. I wouldn't even call it a framework, but it's just a set of C macros that keep things clean, that help sort of with the repetitive nature of how you set up the code to create a state machine where you have an initial state and then want to do certain things every time you exit the state, and every time you enter that state maybe there's an action you want to take. So I've at one time created a couple of C macros that just again in the end make that look clean and compact, but it's under the hood fairly simple. So again, not much of a framework and not much of a sort of an event distribution scheme around it. Just keeping it real simple with the intent is, for me usually, to keep the code clean.
I see.
I would say that my experience matches Chris. Ted had talked about using state machines at the high level. The ones I use are usually at the lowest levels, where they're keeping track of things going down and are fairly simple, just a handful of states.
But the way
it's
way
exactly right. You end up with big things, this nested if, else, then, if, that becomes real hard to try to debug and change. Where state machines, it's real clean, what's happening in each state and how you get from state to state.
Yeah.
One thing I would recommend looking into is the behavior trees. So there's whole theory behind it. And if you Google or YouTube search behavior tree, there's some videos that will show you how to implement it in robotics, which I found it useful.
Kevin, have you done that yourself?
So I've done it with some of my the humanoid robots implementation, but I'm actually going to implement that in my ROS 2 robot, which I'm going to show a little later. I'm starting up a bot-back ROS 2 robot, and the entire focus of the research is implementing behavior trees.
Hey, Kevin, what's the terminology? I'm a bit...
Behavior tree.
Behavior truth.
No,
tree.
Trees. Oh, okay.
I think
Yeah, I mean, this book I'm sharing, I just read a little bit and I thought it's very interesting. Honestly, when I'm from C++ to the state machine, I mean, I don't know if you guys have the motivation to learn about it, but it's a very interesting, different way of thinking, like how the events bring things from one place to another. Yeah.
And John, there are real fast ways to implement those in C, because you can have pointers to functions in C, and you can manipulate so your state vector is basically a pointer to a function, and you change the way you change states is by changing that vector. So it almost maps straight to the hardware.
I think that's one advantage. The one advantage of just one of the advantages of the state machine is the flexibility of being able to. It's a data-driven algorithm that allows you to transition from one state to another without having to code the logic, within your loop that you're executing.
Yeah.
What strikes me is that the state machine, though, the transitions, well, first of all, the states are very well enumerated, but then the transitions between states have to be very well enumerated as well. So the conditions to move from one state to the next have to be very well enumerated. And when I look at this in my mind, I'm thinking just back a couple days to Saturday when David was talking subsumption architecture. And I know it's not apples and apples, but I think of the different states or modes that David's subsumption was in as a state. So you've got your escape behavior or an escape state. You've got your navigate, whatever the different levels were in the subsumption architecture. And I kind of imagine those as states. And the difference here is that you don't really care necessarily which order the transitions go in the subsumption architecture. It's just that some they happen to have a certain order in how you coded them, but then the groups of them have a different priority. Whereas here, you've got very well identified arcs to go from one to the next. So it seems to me like there's an analogy, and there's just similar ways to think about and break down a problem.
If I could follow on to that, Carl, you may remember I described, or I said I wasn't going to describe the bumper and escape behaviors because I said I didn't want to get into it. But basically, that's a state machine or a set of state machines that go through a series. In subsumption, the term is ballistic. A ballistic behavior is one that keeps going even after the sensor has turned off. So each of those ballistic behaviors, for example, you might want to back up and then rotate, is a state. And you go from one state to the next based on, timers or velocity or position or something like that. And you can abort those states. If you don't get if you don't get to where you want, you can return to previous states and so forth. The nice thing about a state machine is that it's real easy to abort. You just reset the state to the first state. You don't have to mess with any variables or anything.
Mm-hmm. Yeah, we used to do it like current state, current input, and then current output and next state. So, and that pretty much describes, you have like, pretty much everything you need to get in and out of a state. So.
Mm-hmm. Yeah,
but I'm kind of with Ray. I'm not sure I can make sense out of this graphic that's on the screen.
Oh.
So my previous experience of state machine is more like I have a bunch of, it's some operations, but I don't want to code it together. I'd rather have a map that it jumps from one, how the sequence changes sealed in the state. But it's a bit different from what I see from this kind of event driven. The event driven is more like the UI type of thing where you don't really know what's going to happen. It's more, for my previous case, it's more I have a procedure. I haven't decided it, so I put the sequence in the map, or I draw out one to the other, but the transition is still determined. And what's happening in the robot is more like you don't really know, there's external events coming in, and then with those state machines, you just define it, and it just magically handles it. So which is, I mean, that if I imagine, I mean, I programmed UI before. It is hard. It's hard. I didn't think of UI as a state. Those handling can be conflicting. So with the robotic and this kind of external events, I think states are important. But, I mean, that's kind of my perception of it. Yeah, good to show you guys this. Anyway, that's kind of my discovery.
Well, Jean,
Recent discovery.
my experience with user interfaces is the same as yours. Sit down and sketch out what the interface on the robot to do, and then sit down and implement it, and I'm stunned at how complicated it all turns out it has to be. And it's like, in particular, because this is not the part of the robot I really wanted to work on.
Yeah. Well, some of that with the state and the UI and all that kind of stuff, it's like eating an elephant. You have to take it one bite at a time. And if you look at the whole thing, like I've got 57 things on this deal, and they all interact, do all these other kind of things, and that overwhelms everybody. So you just concentrate on this little thing and what does it do, and hopefully you're smart enough to not paint yourself in a box here, so that then when you need to do something extra with it, you can add some more to it. But it can get really complicated. In fact, how I'm doing in my current project, we're doing something called it's called event sourcing, but basically we're using events, and we have a handle, and they register themselves with this magic thing that hangs out that says, ooh, this kind of event comes in, guess what? This bit of code handles it. And this bit of code is usually only about yay long or so. And it handles all the things like, well, if this is the code, I need to make sure all of this stuff is off or all this stuff is on, and I'm going to do my thing, and I'm going to say I'm done and I'm off. If you know what I mean, it encapsulates itself. It says, in the case of a robot, we're like, ooh, the stop signal came in. Well, I'm going to send a stop all message, and everybody subscribed to that message, then goes and does the thing when they get a stop all message. You don't necessarily have to then tell, I need to stop all, fine. So in that message, in traditional coding of things, you would say, now I need to call all these things to stop down the list. You go, no, screw that. I got to stop all messages. I'm going to put it out to the event bus, so to speak, and everything that cares about or knows how to do a stop all will then get that message and implement that. So it only cares about itself. Oh, I got to stop all. I'm going to cut down everything I'm doing and go on. And the same thing happens with all the various different messages. So maybe that's one way to approach it, as opposed to doing a whole big gargantuan thing.
Harold, are you a UART serial?
What now?
Are you a serial UART?
Am I a serial UART? I can't. Well, I guess. Well, kind of. No, not really. Not really. But I play one on TV, and I can wear a tie if I have to.
I want to see that.
Harold in a tie, that would be a day. Let's get it.
There's pictures. So
give us your camera back.
Oh, sorry.
He's the talking pie UART.
Wait, hey, David, I had a question for
Sorry,
you.
when I said, oh, you couldn't see me. Thank you for calling me. When I said code's about yay long on the screen, it's usually about that long to handle all that stuff. Sorry.
Yeah, David had a question, if you don't mind, about your presentation last Saturday. I had to leave early because I had to host a poker game. One of the things I was wondering was in my spider leg here, my motor control algorithm uses a coded a PID algorithm. My dependent variable is position, and in your robot design, your dependent variable is velocity. So essentially, doesn't that make the integral term of your PID algorithm position?
Very good. The algorithm I'm actually running is a PD algorithm, and that output drives the integral. So basically, the integral is the output. and it's driven by the proportional and the derivative function. So it's not a real PID controller, but you're exactly right. So if you wanted to make that into a position controller rather than into a velocity controller, you can read the same encoder counts, because really what I'm doing, you're sampling that encoder at a fixed interval, and for that reason we say it's a velocity, but it's actually a change in position. And so you could write the PID controller to treat it as a change in position. I've done some of those. It's kind of fun. You put the robot down and then you push it off center and let it go, and it zooms back to where you started. And then in order to drive the robot, basically you have this fiducial point underneath the robot, and you move it and it tries to stay over that point. So it's kind of like you have a bungee cord out in front of the robot, and you're pulling the robot along by this by moving that fiducial point. You can accelerate and decelerate and so forth. That's how the balancing robot drives around. So yes, so if you look at industrial PID controllers, like for robotic arms or XY tables and things like that, those are almost all position PIDs, not velocity PIDs. Did that answer your question?
Yeah, I think so.
Okay, cool. Does someone else have some more robot-y things to mention?
I got something. So I jumped between research project to some silly project, but this one is somewhat hybrid because I get a lot of pressure from people to jump over to ROS 2. I've been saying no because it's just too much learning, but I finally bit the bullet. So got myself a Nito robot D5. So this is the pop back D5 version. It happened to have a dustbin slot and has the USB access port built right into it. So my Raspberry Pi with the fan fits in perfectly. And also a space for the other Arduino or TC. And also in the bottom, because I cut out the cleaning portion, there's nice space to put sensors and additional electronics, batteries, etc. So my game plan with this is now I have a robot with LiDAR, motors, everything built in intact. I bought it for $70, cheaper than buying a LiDAR itself. So have a robot that I don't have to build, and have a package of ROS 2 that I didn't have to do. I installed everything out of the box, and it's up and running. So from here, I'm going to jump right into the research portion where, like I mentioned before, I'm trying to use the behavior tree, and in order to get to the shortest path problem. So in our house, we have two ways to get to from kitchen to the bathroom, and one is a little longer than the other. And I'm trying to use the ant colony method for marking on the ground. So when it returns, depending on what the sensor picks up, to be higher, like this, based on the IR sensor, how much it reflects back, sort of like how ant plots the shortest path. So in order to test that theory, my hope is to prove that using ROS 2 and also using botback or the package that's already built, I could jump right into the research without having to mess with Arduino programming, etc. So there's multiple things that I'm trying to prove here. But the point I was trying to make is if you want a rover without really messing with it, and a platform that gets you started in ROS 2, this is something worth trying.
So you're saying there's ROS 2 support available for that robot, for that platform?
Mm-hmm. It runs on Raspberry Pi 4, Ubuntu 20.04, 64-bit architecture that you could download the image for your Raspberry Pi. And then there's a whole bunch of packages that you have to install. So you go line by line following that instruction, and then you're up and running.
And it talks to the robot controller over that USB link.
Mm-hmm. So USB from the Raspberry Pi links right into the access port. And the Nitobot happened to have, okay, you got that. So Nitobot
Yeah, I have an older model, so mine is an older model though.
Yeah, it's got the API, right? I think API is the same.
Well, I'm not sure, and that's what I was asking, because mine is, the API is a little clunky. I can't really fully control the wheels independently, only through some workaround. I can get to the LiDAR data, but you know, it's the link is a bottleneck. It's not very it's not meant for API use. It's meant for like factory test. You know, that's what it was designed for, to test it in the factory. Turn the motor on. Is it moving? Okay. Turn the other motor on. It's moving. Yeah. So it's not meant for API usage, but people are using it that way. But what you have probably is a lot better.
Yeah, it's a D5. So D Connect series, I think, has multiple users. So, you know, before robotics get to the SLAM was magic. Now I was able to do this one Sunday afternoon, just no problem. So now I could get to my research portion, which is shortest path problem, without messing with the robots at all.
So in a way, you got a shortest path to the shortest path. That's
Yeah.
pretty good.
Shortest path cubed.
So where'd you get that? Where'd you get that from, and how much did it cost again?
So I got this unit at the Facebook marketplace, $70.
Wow.
The going price is between 100 and 200. It's still cheaper than the LiDAR.
Oh, sure.
Yep.
And you don't have to mess with trying to hook up LiDAR to your robot and all that problems. None of it.
Yeah, the one thing I'm finding with mine is, apart from, you know, the API is not that great, it's on the loud side of things, right? So it's starting to get late here. So if I start driving it around now, and if someone has already gone to bed and the dog is sleeping or whatnot, that thing is making a little bit of noise. So
Honey, what are you doing?
No, I totally appreciate it. That starts to become a big consideration
Oh yeah.
after a while. You know what? I found the very quietest robots I've ever heard were ones that use wheelchair motors. Those motors don't make any noise. They have real high torque, just absolutely quiet.
Probably bevel gears, lots of bevel gears, or helical gears.
Really big.
Yeah, that's going to be one of the disadvantages here with the spider lag going from stepper motors to DC motors. It's pretty noisy. I can't imagine what it's going to sound like with all four legs moving.
It
Basically like a gigantic swarm of mosquitoes.
It should be terrifying.
Well, another plan is to have used your hexapod with 6 legs with all these motors making noise all the time, so your family members get trained on it.
Hey Kevin, you mentioned like ant colony behavior. What or could you describe that? What is that?
Yeah, so I'm not the expert in this field, but one of the computer science biggest problem using our modern von Neumann architecture computer, single CPU, is finding the shortest path. Like me, I got my master's degree in the graph theory, trying to find the shortest path. It's a big problem. But ants or some bacteria figured it out centuries ago with no problem. And way the ant seems to do is when an ant finds a food to a path to the food, it marks a hormone, a pheromone on the way. So when this pheromone dries up after a while, so the next ant that comes up, when it detects pheromone, it reacts to it. So it follows the strongest signature. So over time, when more ants follow this strong path, it creates highway signature for them. I'm trying to use something similar, except that mine will be fast drying ink that will be responding by some type of ultraviolet light to mimic it.
Kevin, we had an algorithm that was similar to that at one point. The idea was that every time the robot ran into something, it had a spray paint can on it, and it would shoot some highly reflective IR spray paint on whatever it just hit, so that over the course of time, it slowly wouldn't hit anything anymore because it would see them. So can you just point a spray can down at the floor and spray along the way as you drive?
Well, so ant colony problem, the way it's supposed to work is what's magical about that is that pheromone have to dry up in certain time. So if you think about it, it's sort of like conceptual Turing machine where you mark 1 and 0, repeats back and forth. That algorithm actually doing the driving, and ants are same way. Ants are like the Turing machine, and that algorithm of if you like it, drop this pheromone. If you don't like it, drop the other set of pheromone. And when you find one, boost it. And that's the algorithm that's built into the ants. And it seems to be working perfectly in solving shortest path problem.
I love it. I love
Robot
it.
droppings.
But does it require a whole bunch of robots though? I mean, does it work if you have only one ant?
So some of the researchers on the computer science figured it out using like, I think eight nodes. I'm trying to do it with the same number, but you know, obviously I won't be able to do it with this type of robot. I got a whole bunch of the Pololo Romy robots. I got like 20 of them right now. So when I actually do, if it's successful, when I actually go down this path, I'll be using the Pololo to actually do it in some open space.
I'd like to see somebody in this group build a robot that's small enough to run off a watch battery.
See, I got this crazy idea of trying to solve the P versus NP problem. So, you know, all my robotics research is actually ultimately headed toward P versus NP problem.
Well, Kevin, the reason I was grinning about that is because I like the idea that there might be simple analog algorithmic approaches to what are normally fairly difficult mathematical computational problems. And it goes back, it's something my dad showed me. He was a physicist many years ago. We're talking about fitting a line, you know, between a set of data points, right? So least mean square, or however it is you do that.
Yeah.
And what he showed me was that you take the data points and they're all thumbtacks on a piece of cardboard, and you put a rubber band at each one, and then you stick a dowel through all the rubber bands and let it go, and it settles into that. It's an analog version of that calculation. Of course, the harder the rubber band is stretched, the more it influences the stick, so it all works out, and you just let it go. So I'm intrigued by that sort of thing, because I imagine that in our own minds, there are a lot of functions like that are doing what we think of as mathematical, but are actually handled in some analog fashion. That's what I think.
There is no digital anyhow. It's all analog, just saturated sometimes.
According to analog devices, anyway, that's what they say. The real world is analog.
There's no such thing as digital.
So your first step is to just do this in your own house using that single node, as it were?
I'm actually using this PodFac to validate using ROS2 to quickly get to the research. That was my excuse for my wife for spending yet another $70. It's not like I don't have robots here. So
no one can have too many robots.
No one can have too many unfinished robots.
Oh.
That's pretty cool. We look forward to following you, Kevin, and see how that goes.
Well, Kevin, you said that you're doing ROS2 because you're hoping that this is a simple approach. And did I understand that correctly? I mean, I don't want to misinterpret what you're saying here.
No, I got a couple of friends in the Korean robotics research, specifically robotics. Dr. Pyo and those guys are are employed by robotists, and they do a lot of research. And people are saying, robot OS is difficult, and I can't really use this to do my research because of the learning curve, etc. So some of us were trying to make a point that no, you could get straight to your research and bypass all this electronics and mechanical engineering, etc., and go right into the pure computation research you want to do. Well, yeah, you're limited to certain type of robots, but it's doable. So that's one thing that I'm trying to demonstrate with this, that now, like even Raspberry Pi is strong enough to house like 64 architecture Linux OS on it. I'm just trying to validate that. And then once I validate it, I want to push it a little beyond to do actually doing some serious research.
Well, you need to keep us informed.
Yeah, the ROS too, because I've been looking at it a while, and all the people I'm seeing facing. Yes, I'm not a cat either, but all the people I'm looking at right now who are now looking at me in the side of my profile have been seeing me do ROS and ROS 2 and trying and failing in all kinds of miserable ways, but then learning some stuff too. The software person in me looks at ROS 2 and said, "This is the way this is supposed to be done." Now, is it easy? I don't know. You're going down the right way with doing Linux sometimes, because I did a bunch of wrong ways. And yes, you can do it with Windows as well, but it's a little bit more flaky. But the Linux, the Foxy Fitzroy, which you're probably running, and on Ubuntu 20.04, it works really nice and goes in really easy. And you can get Docker containers pre-configured, so all you're really doing, like the ExoMi, what happens with the ExoMi here is they have a Docker image. They mount all the source code they care about to a different thing. So you change the source code down here, easy to do. Then you go ping the Docker thing to go reload itself, and now you've got stuff working and going. And some of that's kind of a nice thing as far as development goes. But as far as the architecture goes, with the message passing between the two and all those event things that I was talking about earlier, all of that stuff is in there, and all that stuff is baked in for you. You have to figure out how to use it, of course. But there's a lot of help. There's a lot of help to make that happen. Yeah. So you can literally have something that says, so you're training. You were saying about the state machine and how complicated it could be. Each one of those states can be a literal node inside of that. So you're coding that node to understand just only the things it need to understand, and then communicate to everybody else, "Hey, I'm doing this thing," and let them either care about it or not. It's kind of really cool, actually. Can you tell? I think it's cool.
You get the impression. That's cool. Okay. Yeah, I think I might jump in something here. Just a little bit of a detour if you humor me. I'm gonna...
Really sounded very natural. And some of my friends more than once to come in and basically play with the thing and talk about their interactions with it. And here's the fun part, they gave them one. And this is like an early one, right? So, I mean, it wasn't exactly the way the finished ones turned out. But brought it home and we would play with it. The way it was supposed to work is you turn it on and it would say, spell lake. And then you try to punch it in, L-A-K-E. And if you got it right, it would say, that is correct. Now spell house. Okay, now if you didn't get it correct, it would give you 3 chances. It would say, no, that is not correct. Spell lake. And then after a while, it would say, the correct spelling of lake is L-A-K-E. Well, as we kept this thing, it started malfunctioning. And after a while, it wouldn't work correctly. And it was like the phoneme tables it was scanning or something had gotten farkled. So first of all, it just made up nonsense words. It would say, spell Resnick, spell Resnick. And then you could try, and usually you couldn't get it, and it would say, no, the correct spelling of Resnick is R-E-Z-E-N-I-K, now spell. But then after a few more weeks, it couldn't even make the words at all. And it would just say, spell. And then no matter what you did, and it would finally come back and say,
like
no,
corrupted memory.
that is not correct. The correct spelling of is
And dementia.
unfortunately, they found out about this and they fixed it. And we were massively disappointed. In its very final stages of failure, it wouldn't work at all. It would just sit there across the room and say a word every once in a while.
Yeah, I was going to ask, how long did it take you when you got to where you started talking in 30 words that can say stuff? That's what I want.
It was one of my funnest adventures with technology.
You know,
David, I thought you were heading somewhere on the basis that the TI Speak and Spell was actually Stephen Hawking's voice.
No, the whole thing was they had this new way of doing digital voice, which was, I mean, there was nothing like it at the time. I mean, it sounded great. It sounded natural.
Speaking of college and technology and robots in ancient history, you guys, this club actually gave me an idea here. Believe it or not, I graduated from Louisiana Tech back in 1984, and I was a member of a club called Critical Mass. And believe it or not, one of the primary goals of that club was to build an autonomous robot on early 1980s technology. So what you guys are doing is basically what they were trying to do, at the time. And having recently joined this club gave me the idea of getting together a virtual reunion of our members, and I've started an email chain here to try to get them together. We'll see where everybody went and what they think of technology now. Maybe we'll point them at the robotics website and let them see what they're missing.
Has anybody heard anything from Murray?
Oh, he said he was going to be out tonight because I think his partner's in surgery or something. So
is that what happened?
Yeah. So positive thoughts for Murray and his partner.
Yeah.
Well, hopefully it's not something really serious.
I just we'll send warm thoughts his way. Yeah.
Going back to Saturday for a moment, I really enjoyed the talk, David. I had to watch some of it on the recording though, but there's a lot of nuggets there. I mean, one of the little things that I took away that I want to try out soon is where you have on a per behavior basis, the slew rate. Where for whatever reason, it never occurred to me to do it that way. I always had, a single global slew rate. And it obviously makes sense to have it on a per behavior basis. Yeah, because sometimes, you have this, I had to have these special cases where I want to slam on the brakes. I want to obviously be able to do that a little faster. So, you had to have special cases like that. But having just the slew rate defined on a per behavior basis makes us a lot more general. The avoidance, behavior can, accelerate or decelerate, faster, and user input, you want to do that maybe a little more smoothly. So it's something I need to try, definitely, because that makes a lot of sense, obviously.
Some of the behaviors also, well, maybe that's what you were just saying. Navigation kind of drives through smooth curves, but obstacle avoidance sometimes need to turn real sharply and real quickly.
Right.
And a sonar that can see things, 12 feet away can avoid those things with just a little tiny adjustment, whereas if it's 6 inches away, it requires a fairly powerful adjustment. So what I like about those is that you can tweak them by hand. You control the amount of the turn constant or the velocity constant, you control the amount of slew rate, and watch the robot behave and tweak those by hand until it has the desired behavior.
But isn't that in effect what the PID algorithm is designed to do, or is your slew rate effectively a fail-safe where the PID algorithm won't quite do what you want?
The PID sort of sets a upper limit for how fast the signal can change. So in a sense, it is also smoothing out the control input. But the slew rates that Chris is talking about are individual. Basically, think of them as reaction times of the various sensors.
So it's almost as if you created an artificial mechanical response that the PID control is reacting to.
I'm not sure I understand that.
Well, when you use a PID algorithm to control a ship, the ship has a certain behavior in terms of how fast it can turn or respond to rudder actions. And by introducing a slew rate before you even get to the PID algorithm, essentially you're just creating a sort of a simulated mechanical constraint.
I'm not sure.
Let me try, because I can try to explain the exact problem I was recently having, which makes me want to try this per behavior slew rate. So my use case, a much simpler one, because let's say just two behaviors. Behavior one is user input. Okay, got my joystick here. So I give it a speed command, right? I can step on it, so to speak, go from 0 to max speed instantaneously, right? As a user, I can do whatever I want, but I don't necessarily want the robot to immediately output full power to the wheels, right? It'll be very jerky movement, right? So I have a slew rate controller where even if I go from 0 to full speed, it just will ramp up to full speed, right, at the defined slew rate. Now, at the same time, I have a avoidance behavior. It wants to slow down and steer, but it may have a reason to steer faster and to slow down faster than I do, with my remote control, right? And so now with my single global slew rate, I'm having trouble finding the sweet spot, right? Versus, like David has shown, I mean, this should just be defined on a per behavior basis. And you can kind of say, well, if you have an avoidance behavior that wants to slam on the brakes, or maybe it's the cliff sensor on my vacuum robot that knows I'm about to go off the stairwell, right? You want to slam on the brakes. Well, I need to slam on the brakes immediately, right? In that case, I don't want to slow down sort of smoothly. And so it makes, by just letting that slew rate be defined on a per behavior basis, you can account for these different scenarios in a much easier way. You don't have to find a single parameter, that works across the entire range of behaviors. So I don't know if that explanation helped, John. But
I think that's a good explanation. Does that apply to what your question, John?
I guess. I was thinking of it.
Or you could just have a junky robot.
So can I have a question observation? So David, do you ever change the gains on your PID controller?
Change the gains on the
You mean it?
Is the gain for your wheel motor? I guess you have a velocity loop on your wheel motors, right? So the PID is closing about the velocity on the wheel motor. Okay. So do the gains for the PID loop on the wheel motor velocity loops ever change?
No.
Okay. So you have, if I interpret this correctly, you have the PID loop tuned so that you can have the best kind of response that you want from velocity input to wheel turning speed output. So you have that loop as tight as you can. The instant you change the velocity to your motor, you want that to respond in as good as it can mode. Probably a perfectly damped response. So then it strikes me that what you're doing with the slew rate limit, a per behavior slew rate limit, is that you're basically defining an acceleration limiting function on a per behavior basis.
Yes. Yes.
So you could accomplish an acceleration limiting function a lot of different ways, right? You could put a PID loop. You could feed the output of your controller, Chris, into a PID loop and take the output of the PID loop and feed that to the input of the wheels. And then you could have a different gain for your controller, PID loop, or you could use a low pass filter, or you could do any number of different functions. It's just that with a slew rate, it's a simple implementation and it's a clipping kind of function, but it's nice and simple. So
I think that's accurate.
When you say gain, you're not talking about the coefficients applied to each.
KI, KD, KP, those
Okay,
gains.
those are the coefficients. All right.
Those
yeah,
are the gain, the coefficients, the gains. And I asked because in my robot designs, so what I noticed was that when I started with the 2016 Club robot, it was using that whatever standard library is for PID in the Arduino space. And I noticed that in the 2016 robot code design, it was using a same gain set for every condition. But then I noticed as I was reading through the documentation on the library, is that it was that controller, that PID controller, was specifically designed for adaptive gain control, so that you could, based on the different state that you're in or the different behavior you're trying to exhibit, you could on the fly change the gain of the PID controller and change its response instantaneously. And the way the PID controller was designed, it would give a smooth response, but it would follow one gain until you flip the switch, then it would follow another gain.
I can see a reason for doing that. And I will say in the helicopter, I can fly with different gain rates depending on how hard I want the thing to turn. So let me back up a minute. And you sit down and tweak the parameters for a PID controller. And, you can get it so it's optimally damped or underdamped or however. But my point is that there is an aesthetic part of that, which is that you as a robot builder, you have a certain amount of mass and momentum in this robot. What do you, when it's operating properly, what does that look like to you? Is it very angular and sharp, like the head of a CNC tool, or is it more, curvaceous and graceful?
Organic.
So to begin with, there's not one right control setting for the PID controller. Having said that, the mass and the torques and all those things don't change. So once you have it adjusted, the only reason I can see for wanting to adjust the gains on the PID controller is if, for example, you picked up a heavy weight. So you actually have changed the physical
response.
But even then, it's probably best just to get it tuned and leave it alone. So, and I would also then talk about that there's actually reactions happening from both ends. That is, what Chris is describing is me telling the motor how to accelerate. Well, I'd like to accelerate along this smooth. But there's another piece of input coming in, which is that the wheels themselves, they may be running over rough, uneven spaces. And you want the reactions to those to be instantaneous or as quick as possible. So the input that's coming from the outer world needs to be responded to immediately, but the input that's coming from you might want more graceful curves. So I hope that helped.
Cool. That answers some questions for me. Thanks.
Is that the slew rate applies on the input?
It supplies from the output for the behaviors on the way on the input to the motor control.
I see. Yeah. Okay. Thanks.
Yeah, the lecture will be put up on the YouTube, right?
There's some echo going on.
It's already up there.
Okay, I wanted to rewatch it.
Yeah, PID is certainly a very interesting topic, from a mathematical perspective as well.
Yeah, and the guys who are really into that stuff, it makes it clear how much I don't know. There are these three-dimensional planes with poles that go off to infinity and holes that go off to infinity, and you have to stay in this space right here, or you'll fall off the edge of the world.
There's Bodie diagrams. You don't want a gain of 1 and 180 degree phase shift because it's unstable. So.
Well, one of the things I'd like to do with my latest modification to my motor driver is I've got a couple of debug pins coming out of the board where I'll be able to examine the current versus the position of the motor. And I'm hoping to be able to get some interesting plots out of that to see exactly how my PID algorithm is performing.
Hmm.
Do you expect to see as it goes through a high gain angle that the current will go up?
Yeah. But I also would I want to use that to see if I can tune the behavior a little bit. I mean, PID control doesn't really factor into this design very much. It's just kind of something I wanted to play with. If I didn't have any PID control involved, it would probably still work more or less just fine. I just didn't want to get into a situation where the movement of the legs was real jerky, or if it got to a point where it was twitching back and forth. But I've got that covered with the deadband,
Yeah.
So it was just something fun to play with, really.
Well, we talked about that a little bit Saturday. That might have been after you left, but in response to a question Ted asked, essentially about using a PID controller to dampen out oscillations around the set point versus just using a simple linear controller with a dead zone. And, the PID's probably the more precise, cooler way to do it, but it's a whole lot more trouble to set up and tune and adjust and make happy. A simple linear controller with a dead zone works a lot of the time. It doesn't work all the time, but it works a lot of the time.
I tried to actually set it up with one of the worm and worm gear motors, and I basically made the motor drive proportional to the difference between where it was and what the target was. So as it got closer and closer, the drive would be less and less, and it should slow down. It never gets there. So I had to actually basically do 2 drive levels, one at full speed to get it there as fast as I could, and then once I was like 50 counts within my target, I actually had to reduce it down to only 64 out of 256, and it would actually make it to the target. So
Ray, you may remember in the talk I made a reference to the robot slowing down as it approaches the waypoint based on the distance to the waypoint, and
Right.
that you can actually let that go to 0 because it'll stop before you get there. You actually
That's right.
you have to clip it at some what's the lowest speed I can go value.
Yeah. I thought that would be a neat approach, and then I realized, it's never going to get there.
Yeah, exactly. That's the same thing
Yep.
No, I thought it would hit 0 just as it hit the waypoint.
Yeah.
But the robot actually stops moving before it hits 0. So.
Yep. Yeah, that was my experience too. And it's kind of like, well, that was such a neat idea.
How much is that just because the motors can't drive as slow as you'd like them to drive?
Well, there is some lower limit, that is, there's a bit of hysteresis when you start at 0 and then just start increasing the voltage by microvolts. There will be a point at which it suddenly begins turning.
Right.
And so it really doesn't do any good to fall below that rate. So, so you want to clip it. Interestingly, at least the tests I've run on my robot, that's a kind of a bidirectional thing. So there may be a jump on, but then when you slow back down, you can actually go slower once you're moving. That may be a static versus dynamic friction kind of thing.
Right, and kind of depending on the gearing, you could turn the voltage all the way down, and if it's moving, it'll continue to roll.
Yes, just from the momentum of the,
Yeah. My spider leg motors won't operate below about 15 to 20% duty cycle.
Mm-hmm.
Those Ted, if you're running a PID controller on those, the PID controller will actually act as brakes. That is, if it sees that the thing is going faster than it wants it to go, particularly if it wants it to go 0, it'll reverse the voltage and even drive it negative if necessary to so even though you don't have brakes built into the hardware design, the PID controller will brake so you start down a real steep slope or something like that. So, but yeah, if you got 81 gear ratio, you're not going to do any coasting.
Right. Anyway. Well, I can tell you guys what I've been doing.
What's up, Ray?
Let's see, I think I'm going to try to do a quick presentation.
I want to know why it says, what do you want to present? And you say entire screen. And it says, okay, which screen do you want? Or do you want the entire screen?
Yeah.
Well, it kind of makes sense if you have more than one screen, but if you only have one screen, that's a stupid question, isn't it?
Yep.
And another thing.
Okay. This was a guy that had done, I really like his design. I think he is from Malaysia. I can't, you can't understand what he's saying, but he had some really neat designs. Can you see that?
Yes.
Yeah. He used DC bicycle motors. They're, I think, 350 watt, 24 volt. And that was one of the things I wanted to try to find out. And it's actually like a skid steer. And that's his latest project. And I think you can switch in different motors and with cutters and that kind of thing. The other ones that he did, he actually has a generator on it. And let's see if this one, yeah, this one can actually pick this thing up. Let's see. This isn't the one with the generator on it. That's just an RC one, but it was I thought a very neat layout.
That looks like Ted's geometry for front to back and left to right.
Let's see if he's still got the other one up here. It doesn't look like he does. Let's see.
That's a pretty cool idea, though. A robot that can swap out its own components.
Yeah. Anyway, so he had a generator on the previous version of this one that was fixed. You couldn't interchange the mower decks. And I had been looking at lithium iron phosphate batteries, and a 12 volt 100 amp hour is right around $900. So it's an awful lot of money to invest in a battery.
That was, what were the specs again?
It's 12.8 volts and 100 amp hours.
100 amp hours.
Yeah, and
so like a standard car battery.
Yeah, you're not. They don't recommend using them to start engines with, though. Apparently, they're better for, because you can, an engine starter may require hundreds of amps. Like
so you want 1 amp for 100 hours and not 100 amps for 1 hour.
Right. Anyway, so to get around that issue, he and I think this guy realized that as well. You could add and I'm going to stop presenting here. Okay. Okay. Did it stop presenting?
Yes.
Okay, good. Anyway, so I had been using riding mower batteries, and riding mower batteries, again, they're to start the motor. They're not to draw, current out, 10, 20, 50 amps for an hour. They're just not designed to do that. So what I did is you can buy, if I can get this out of here. Okay, this is basically an automotive alternator, and you can replace the regulator inside of it. Instead of producing, the charging voltage for one battery, you can do it for 2 batteries or 24 volts. So it's very, very inexpensive. I think this was just under $20. But this thing was designed to output a certain current, and I don't know what that is, but I wanted it to, most of them are around like 80 amps or so. And if I double the voltage, I'm not certain if the current would be reduced by half or not. And it depends on which one of these. You can get them for up to 200 amps if you want an alternator that produces 200 amps. Anyway, so I'm just gonna hook it up and see what it does, and then that way I won't have to, spend. And that was just for one battery, and I need 24 volts, so I'd have to buy 2 batteries, $1,800 worth of batteries. They are neat. They do last a long time, but I had the alternator already, and it was a pretty cheap, thing to do. So instead of getting battery or energy from the batteries, I'm getting it from the gasoline engine, and it's spinning an alternator and keeping my batteries up. So that's what I've been doing. You can buy these, they're called thick washers. Some of them are, depending on the size, they'll have like a 3/16 inch thickness. So instead of drilling holes in things, you can just weld these washers onto a plate, make a bracket to hold the alternator. And it's a whole lot quicker, and you don't go through a bunch of drill bits because, the metal is fairly thick and the hole's pretty good size.
So, Ray, this is a hybrid lawnmower?
Yeah, it's got wheelchair motors to drive. Basically, it's got a gas engine in it and the mower deck, but it has wheelchair motors and 2 12-volt batteries to develop 24 volts for the 24-volt wheelchair motors.
And the gas motor spins the blade?
Yeah, it spins the blade, and hopefully it's going to spin this alternator soon. And that's what I'm going to use basically to generate enough power to keep the wheelchair motors going and not, draining in like 10 minutes or so.
My car works like that. I get 60 miles to the gallon.
Your car? What do you mean?
My car uses the gasoline motor to charge batteries for an electric motor, and I get 60 miles to the gallon.
Oh, really?
Yeah.
So what's your car?
It's a Prius.
Oh, it is. Okay. Yeah. So same sort of thing. You're using a pretty good size generator to keep your battery up.
Well, but is it? Because I thought on the Prius that the battery of the Prius is basically recapturing braking force power and then using that for the torque needed to accelerate.
The gasoline engine can also just drive the electric motor, even if you're sitting still, and charge the battery.
In other words, basically for the first 30 miles or something like that, I forget the exact number. Anyway, for the first 30 miles, it can be run on battery only. After that, it's basically supplementing the battery. So to get that longer range of 300 or 400 miles. So hence, that's how you get the higher miles per gallon.
Yeah,
Because the new Ford truck that's coming out is a hybrid, and it gets like 40 miles per gallon.
I've got
it uses the battery.
We've got a Chevy Bolt, which is the all-electric car, and it's kind of like you really want to rate it in terms of pennies per mile rather than miles per gallon.
Mm-hmm.
So otherwise you don't get much of a good comparison. But you talk about the way it regenerates, charges the battery as it brakes. I drive it in the low setting, basically what it looks like low gear, on the shifter, but generates the most regenerative braking, and it lets you drive in what people call one pedal mode.
Yeah.
Where you never really hit the brake.
That's right.
Yeah.
Until you roll up to a stop sign, you use it all the time, and it takes a little getting used to letting off the accelerator and having the thing brake for you.
Yeah. The Prius works the same way. My first impression was when you, every car I've ever driven in my life, you know, when you let off the gas, you coast. Engine goes into idle and you coast, and that has a certain feel. The momentum and weight of the vehicle has a certain feel. When I would take the foot off the gas in the Prius, it felt weird. It was slowing down more than it should.
Yep.
Yeah, I had a Nissan Leaf prior to the Bolt, and the deceleration in the Bolt when you let your foot off the accelerator is greater than for the Nissan Leaf. So if you ever get a chance to test drive a Bolt, you'll know what I'm talking about.
Ray?
VOLT or BOLT, because they make both, right?
Yeah, they made an unfortunate mistake there when they came out with the pluggable hybrid called the Volt. And so when people now think the Volt is the full electric, all right, and it causes a lot of confusion.
Ray?
Yeah.
BMW electric vehicle, I think i3, that one, I heard it from my electric vehicle club that has the unit called Battery Saver, which was by law, they have to install it on the California vehicles. And that's like the generator. So it's got like 1 or 2 gallon tank with small generator built in.
Yep.
And I heard that's very efficient because you could charge the battery cells in the electric vehicle. And I was told that a lot of the California guys, after buying i3, they sell it away. So perhaps we could use that for your purposes.
Yeah. They actually, it's like a very low power. I think it's a 2-cylinder engine, and the i3 had what they called limp mode. You could get, if your battery ran out, you could get home driving like 35 miles an hour with the gas engine, and it did not. A lot of people did not like that. And the range on the i3 initially was not that good. And
well, I have a very esoteric complaint. I commute every day, and so I have to do a lot of things to keep myself entertained. And one of the things I do is when your car pulls to a stop at a light, it leans forward on the suspension. And if you carefully control the brake pedal, you can minimize that. But typically, when you actually come to a stop, there's a little jerk back as the suspension recenters. And so over the years that I've been commuting, I practice reducing that jerk back to 0. And I can do that in every car I've ever driven except this Prius. And the Prius is either using that slow velocity to charge the battery, or it's driving, the electric motors are driving you even though you're just barely moving at all. But I have found it impossible to eliminate that last little rock back in the Prius. And I've been trying for months now.
Try it. I got Prius too, so it's.
You know what I'm talking about?
Yeah.
There's the cool little display where you can see where the power is being generated and consumed and everything. So I watched that display to see if I could figure out what is it doing that's preventing me from doing this nice, smooth, perfect stop. But so far I have not mastered it. I'll keep you all informed.
So David, are you a hypermiler?
What does that mean?
A hypermiler?
I guess that means no.
It's the idea is to get the most fuel efficient thing you can do. And there's been reported that you're 60 mile an hour, 60 mile a gallon, that some of these hypermiler guys claiming over 100.
I think I could see how if you were real careful about when you accelerated, there's never any reason to put on the brake. If you put on the brake, it means you use too much gas to begin with. That if you were really careful, you could probably do really well. But I have noticed here in the last week, I've been running the air conditioner. It's dropped down to about 50 miles. I've lost about 10 miles to the gallon.
I will tell you, this hypermiler thing came out, I don't know, 10, 15 years ago, longer than that. But I was doing a radio show one time. Me and the co-host there were thinking, well, let's give this a try. So on our next tank of gas, we used a couple of techniques. Didn't know what we were doing. Didn't really understand all the things, not practice. And the deal was you couldn't go over 60 miles an hour, and you had to do your best to never stop and never hit the brake. Roll through and ease on your, no jackrabbit starts, piss the guy off behind you, but we're doing it. It was painful because I wasn't used to it, but I will tell you, I used to get about 350 to 360 miles out of a full tank of gas because I, a big truck. I did this in this one tank. I got a little over 400 miles on the same, and I wasn't very good at what I was doing. So you could do way more. That's just, it's a conventional truck, not anything special.
Harold, I'm pretty sure that term started with the gas craze of the late 70s or whenever that was in the 70s.
Okay.
And there was people who would, as I remember it, they would, just so that they could goose up the specs and claim the pole position, they would shave down the tires so they're super narrow, and they would pump them up to hundreds of PSI, and they would cut out every bit of weight on the vehicle except for like the seatbelt and whatever they had to do.
Yeah.
And I think that doing that, even in the 70s, they were able to get like a bit over 100, maybe even per gallon.
Well, I would tell you,
but it would be on a course, right? They would start it, and then it's just like you say, there's an too slow, and it's inefficient, too fast, too much wind drag. So they would have to go like 17 or 20 miles an hour, and they'd just do it for a couple hours on their 125 PSI bicycle tires on their car, and they could get like 150 miles a gallon.
This is me just normal driving though, nothing crazy on the thing. And it just, I remember it being painful to maintain that for a whole tank of gas.
Oh yeah.
And because I'm like, I really want to go, but no, this experiment, we're doing this. And it also showed me that how much gas we actually waste with the braking and the going fast starts, which for the most part is unwarranted. It just makes it too good.
Not to mention that hot exhaust coming out of the exhaust pipe. That's energy just being thrown away. You have paid for it, just being tossed away. I can't help but think that, gentlemen, we're going to wake up one day and there's going to be some announcement in the news of some new battery technology, and all these problems are going to go away. Is it one battery, you only charge it once and it lasts your whole lifetime? I don't know, some cold fusion battery. I don't know, but there's been so many changes that have happened just the last 10 or 15 years with battery technology. And there's a lot of money, research money flowing, and there's going to be some breakthrough in this.
That can't ever happen. That can't ever happen, Mr. Anderson, because what are we going to fight over when we don't have to fight over energy?
Oh, that's never been a problem.
Well, there was one of those announced just another few weeks or a month ago, and the cool thing was that the battery was not subject to fire problems like LiPo, and it had a similar energy density or better, and it had a charging rate that was like many C. So you could take whatever it is, 70 kilowatt hour battery for like a Tesla, and you could charge it in 2 minutes.
Yeah, something like that.
The trouble is what happens to the power grid when all of a sudden you plug that car and you say, okay, charge, and then the neighborhood dims while your car charges up, right?
Yeah.
The power grid can't handle it, right? Just think about it, right? How many houses got crippled when we started plugging in switching power supplies for desktops?
I can see us as a group meeting up one day, going in, we're all plugging into here now. Let's all see what happens. It'd be like the Marvel movies when superheroes get their power. You just see the blackouts start happening as they go across.
Bring Magneto.
Well, actually, one of the advantages of all these electric cars coming into the market is that it actually evens out the power distribution, because when do people charge? They charge at night typically on their cars. So they're charging during low consumption periods, and it's kind of smooths out the consumption curve for the utilities.
I want Mr. Fusion.
Yes,
Banana
peel. Yes, I'll +1 all of that. So how do I've seen that, what I've seen coming in. I mean, I guess this is a little bit robotic, sort of. What the hell is a solid state battery, and how does that work? Anybody know? I've seen that references a whole bunch of times. I'm like, aren't all batteries pretty much solid state unless they're that liquid other thing going on there with the methane or something?
Probably just a buzzword. It's probably a
like the
buzzword.
fuel cell.
So there's a gentleman named Dr. Goodenough. He's pioneer on LiPo batteries, and now supposedly 2 years ago, he's got the solid state battery solved. And last year, Elon Musk supposedly met him, and then now he's gone. I don't know what came out of it, but supposedly 2 years ago, the announcement was solid state battery can now be mass produced.
Well, now
But we don't see any yet, huh?
they didn't actually answer the question of what it is, so I'm looking it up. It says solid state battery is a battery technology that uses solid electrodes and a solid electrolyte instead of the liquid polymer gel electrolytes found in lithium ion or lithium polymer.
Okay, isn't that like a dry cell D battery we've had forever? You know, I don't, you know.
Yeah, in other words, it's a buzzword. It's nothing new. It's a buzzword.
So the thing about batteries is it over time, because it is operated by chemical reaction, it creates dendrite, and it causes fire hazard. So just the fact that you make it, you know, without you depending on chemicals, you could pack more without the risk, and that's one of the benefits, from my understanding.
Yeah, well, even I understand
like
one of the problems. Go ahead.
I can see that because you know all those dry cells and a bunch of other things after a while all the electrolytics and all that stuff breaks down and it gets you know it has that corrosion stuff and all goes to crap, right? And
yeah, and I imagine if you're going to charge it in 2 minutes, that those forces get worse.
Yeah, and
No,
so
you know, I've seen photomicrograms of those little icicles growing out, you know, and it's pretty intense when you look at them. You think, good God, how did that ever work? You know?
Yeah, and it's not so much corrosion with lithium ion. The lithium actually migrates from one side to the other, and eventually it becomes permanent. It won't go. The lithium goes where it shouldn't go over time.
Maybe we need some biologically inspired, you know, fungus-powered batteries or some other.
I pull my finger, I'll give you some fungus.
Oh boy.
Where's the potato-powered robot, huh?
Yeah, a whole cart full of potatoes.
Potato bot. That's what we need, the potato bot contest.
But on the serious note, the battery is holding everything back, right? Because robotics is batteries the big problem, electric vehicle. It's just hunk of fire hazard material that weighs a ton. You know, if you could solve that, make it really light and safe, then I expect electrically powered airplane taking over very soon.
Nova just came out with one of their programs on what they call the electric airplane race.
Yep. I saw that too.
You might want to watch that.
Yeah.
Plus, really there's the rare earth problem, right? Where right now all the chemicals are in a very sketchy kind of part of the world. But that one battery that I mentioned was announced a few weeks or a month ago. Apparently, it's using materials that are much more readily available around the planet, not just in China.
See, that's what I don't quite understand. I mean, if I remember correctly, I was told there's about $1 trillion worth of lithium sitting over in Afghanistan, except those people could be sitting high on the hog like Dubai, but they can't get their act together to stop killing each other. That's how I heard it. I don't know if that's true or not. But
I think it'll be in a technology that we haven't currently envisioned.
Okay.
You know, those sort of thing happens all the time. And it'll change everything. You know, one of the reasons the Wright brothers were able to build an airplane and everybody else was able to build an airplane was because all of a sudden you had these lightweight gasoline engines.
Yeah.
It wasn't the aerodynamics problem had in some ways been solved. But it was the fact that you had these lightweight engines that made flight possible.
Right. And certainly with all those drone things that come out, you know, what was it? I don't know, 10, 15 years ago when those brushless motors started coming out and powering the drones, it had that power to weight ratio that was through the roof, where you just took the motor, you slapped it on a piece of flat cardboard and it flew, you know?
Well, and now an outgrowth of that is we have these electric bicycles. with a little tiny cordless motor and a little tiny battery, and they go 50 miles an hour for hours.
Yeah.
So
Yeah.
I'm hopeful there'll be some battery revolution around the corner.
Me too.
Gentlemen, on that note, on that hopeful
There you
note,
go. That, and I was going to say a TARDIS. We need a TARDIS revolution.
Yeah.
All right. So, well, here we are, 10 o'clock, Dallas time. Anyone else have anything they'd like to bring up for tonight?
Yeah, Carl, the Frontiers of Flight Museum sent me a request to say whether we're going to do, their Moon Day celebration. It's either the 20th or the 21st of July, and you can do it virtually now. So they're just looking for an answer back as to whether we're going to do anything or not.
I was just taking temperature of those on the call right now. Unscientific survey, who would be interested in supporting? So the Moon Day is, the annual celebration of landing on the moon, and the Frontiers of Flight Museum in downtown Dallas
Near Love Field.
have a gathering, a celebration for that, and DPRG have traditionally, pre-COVID, gone down and set up a booth to just demonstrate stuff. So it's been nice. Most people have enjoyed it that come by the booth and see. So just to show hands, who on the call would be interested in taking an afternoon and manning a virtual booth, for example?
Yeah, I'm not certain how they're going to do the virtual booth or whatever.
Or in person. Yeah.
So
Say
how
it
are
again?
they going to do the virtual? Because in case of half of these people, they're not here. So
That's kind
I'm
of far
thinking,
from Chicago, but
right.
Yeah.
So I'm thinking for those people that might want to do the virtual, but how are they going to do it? Will they have like slot times that they'll have like a camera and can demonstrate, or will they have interaction?
Yeah,
So,
they didn't provide any details. I'd have to contact them to.
so you might get a little more info on that front because that half wouldn't be.
But John, just regardless of,
I know.
you
Well, I'm
mentioned,
just saying for the virtual aspect, because the virtual does sound interesting from the virtual aspect, and so how can we incorporate the virtual into it?
but
Would be
I'm
the
asking
question.
from a practical perspective, from a club point of view, would anybody on this call just for interest be interested in manning a booth for a half a day?
What
And what
is the
day is
task?
it?
What day? Yeah, what day?
It's either the 20th or the 21st of July.
Happiness mode.
What does the task entail? Just sitting there and handing stuff out, or
Normally just show it. We'll have like a robot or two there that we built,
Right.
and they answer
Usually several
questions.
different displays.
Yeah, what we built, we have run stuff around on the ground, answer people's questions.
Right.
Yeah.
okay, so you're looking for somebody who has something to demo.
Well, if someone's interested to demo, yeah, something that they have where they want to demo and something that they're interested to demo.
Well, the
Yeah.
the 20th and the 21st of July, that is a Wednesday, that is a Tuesday and a Wednesday, and that's going to pretty much preclude me from.
It's usually
What day?
Saturday though, isn't it?
Yeah, usually it's Saturday.
Yeah, well,
Are you certain, Ray?
I'm looking at my.
Yeah, for certain. It's usually right around my birthday is the 21st.
I know,
it's
but
my birthday, like
in their
3 years
email,
in a
did they
row.
say Saturday or did they actually say during the weekday? That's what I'm trying to figure out.
I'd have to find the email, John.
Okay.
The Saturdays, the 17th and 18th, or the 24th and 25th. I can't read a calendar anymore, which that may be true. I can't read a calendar.
Okay, there it is. Moon Day. I'm looking it up now.
Okay. Now, what we could do is probably, if we are there, one of the things we do have in the past was have like a video of the different robots and actually show it on a monitor screen in addition to having the robot there. So for
it looks like July 24, Moon Day 2021.
Okay. Oh, you found it then. Yeah, this doesn't say on the thing. You'd think they'd include that.
So
Okay, well,
Okay.
let's just, you
I
know,
would
if you
say
want to
mull
send it
over
to me,
it for the
Ray.
week, and then we can talk next Tuesday
Yeah.
and fine
Yeah.
tune
I'll
it.
Sure.
I'll ask him what the you know
Yeah, and
how
ask
are they
about the
setting up
virtual
the
part because that is part of the iteration nowadays.
Yeah.
So
Yeah. Okay.
Yeah, cool. If you could let me know, we can get it on the official calendar, see if we're going to participate or not as a club.
Yeah. Yeah. If you don't want to, there's always next year.
Yeah, I think I should have something to show, and that's possible. I just need to plan it with the wife, my social coordinator, and hopefully by then there'll be a little autonomy. But this ExoMod is already set up, so we could give somebody a pad on a web page and have them drive it around. That might be fun.
I think that would be good.
Cool.
Okay.
All right. Well, if there's anyone else, anything else?
So basically, I think that sounds interesting, but I can't commit that far in advance.
Yeah, I'm going to be in a sling. By the way, I got surgery on the shoulder next Tuesday, so I don't know what's going to happen after
Literally
that.
in a sling, not just in a bad way to coordinate things, but literally in a sling. Got it.
Literally.
So this means you really do need a personal robot helper to go get
maybe
stuff
we
for
could
you.
borrow one of John's
Wonder where I could
arms.
find some of those.
Yeah, who's got a humanoid? We set up a chatbot, and that would man the booth.
Yeah, that works. Virtual. Okay. Hey,
All
John,
right.
if I could bug you after everybody goes, just a quick question for you.
Okay.
But I don't have anything else. Does anyone have anything else for the night?
No.
No. All right. Well, we'll call it a great meeting, and I'm going to stop the recording.